Offered to students for about 20% of their learning time in school, Engage is a STEAM-like opportunity that invites kids into project and problem-based activities that integrate elements of science, learning technology and technology education, engineering, the arts, and math. Engage is structured around the four main elements of the Materi Group's Engage for 21st Century Learning framework: digital age literacy, inventive thinking, effective communication, and high productivity. Each challenge is designed to provide students with as much choice and voice as possible during this 20% time. One particular challenge centered around students' wonders about flight. Students were provided with protected time and opportunities to explore, design, create, test, and redesign a flight object of their interest that would dig at their wonder about flight. One team chose to work on the design of a hot air balloon, with the goal of using a range of materials and heat sources to design a balloon that would float as high as possible. The students' experience would culminate in a school-wide launch day where every team would share their design and launch their flight object. As launch day approached, this particular team had made several iterations to their design, often scheduling before and after school work times, test launches, redesigns, and build sessions. When launch day arrived, they had not yet discovered the material or the heat source that would support their hot air balloon design, and were told by one teacher that they had failed to meet the challenge. If we go back to the Engage framework, however, and consider the iterative process in which this team engaged, we can easily identify the wide range of ways in which the team met and exceeded the objectives of the challenge despite the fact that they had not yet gotten their hot air balloon to float. Beginning with digital age literacy, our students used Moodle, our learning management system, to build forums for exchanging ideas, making connections, providing support, offering suggestions, asking questions, and pushing the thinking of those within their flight object team and those across flight object teams. They also built a Diigo network where they were able to collect and curate resources and content that would help other teams as well as their own team with design ideas, material suggestions, and other flight plans. When we move on to consider inventive thinking and problem solving, students were encouraged to tackle unfamiliar challenges without obvious solutions throughout this project. They brought individual sets of tools, materials, ideas to the table, and the teams had to work to blend these elements and approaches to mold a solution. Students compared, inferred, interpreted, analyzed, and evaluated a wide range of scenarios and settings, and identified individual and team goals specific to the challenge, research, flight objects, design and build plans, and the launch activities. Teams work to manage individual time and collective time, to attain goals and to assess personal and group performance, to assess learning, and to assess their flight object in light of their goal. Digital tools were also used, which were new to several of these students, and drew on their ability to problem solve and think innovatively about their application. If we move on to effective collaboration and communication, in addition to the elements we've already discussed, students had to cooperatively interact with one another and others as they read and managed their own emotions, their motivations, and their behavior on this project both in and out of class. Students were called to work effectively with others to confront their flight challenge and to ensure that their design was authentic and agreed upon by all members of their team. This fostered a learning environment for students through positive exchanges and meaningful dialogue, both face-to-face and electronically, and called on students to effectively communicate and contribute using our digital environments, including Moodle, email, and Wikispaces. As we move to our last component of high productivity, teams had to prioritize, organize, and lay out their entire project. They conducted research of real-world flight objects to compare and discuss attributes for design of their own project and their own object. They created their flight object and used digital tools to be as productive as possible. Although this team may not have met their formal goals specific to their flight object, it is imperative that we help students recognize the fruits of their efforts and the learning, both formal and informal, that consistently takes place in the cracks of the process.